Imagine a force more powerful than any nuclear weapon, traveling at 1,000,000 miles per hour. It's invisible, silent, and capable of taking down every piece of technology we rely on. Your phone, the internet, the power grid, all of it, gone in an instant. This isn't science fiction, it's a very real threat that almost plunged the world into a new dark age. This is the story of America's closest call with a catastrophic solar storm, a moment in history that proved just how fragile our modern world truly is. The sun's hidden power. For billions of years, the sun has been the giver of life, a constant source of warmth and light. But it has a dark side, a tempestuous nature that can unleash unimaginable fury. Occasionally, our star belches out colossal bursts of energy, known as solar flares and coronal mass ejections, or CMEs. These are giant clouds of superheated plasma, packed with charged particles that rocket through space. Most of the time, these storms miss us, passing harmlessly through the void. But when one of these solar tsunamis hits Earth directly, the results can be devastating. They create what's known as a geomagnetic storm, a global-scale event that can overload power grids, disrupt communication satellites, and fry electronics. We've seen it happen before, on a smaller scale. In 1859, the famous Carrington event sent telegraph wires into a frenzy, sparking fires in telegraph offices and even allowing some operators to send messages without power. Hey, it was a wake-up call, but a century later we'd forgotten the lesson. We had built a world of intricate electronics, a sprawling web of power and communication that was unknowingly a sitting duck, the Halloween storm. In October 2003, the sun let loose. It wasn't just one flare, but a series of them, like a machine gun firing off rounds. Scientists at NASA's Goddard Space Flight Center were tracking the solar activity, watching a monstrous sunspot, a dark, cool area on the sun's surface, grow to a size larger than Jupiter. It was the most active sunspot in decades, a ticking time bomb waiting to explode. On October 28th, it happened. A massive X-class solar flare, the most powerful type, erupted from the sunspot. It was a direct hit. The CME was traveling at an unprecedented speed, hurtling toward Earth with the potential to ignite a geomagnetic storm of historic proportions. The immediate impact. The first signs of the storm arrived in a blinding wave. The powerful burst of radiation slammed into Earth's magnetosphere, causing a global-scale aurora that was visible as far south as Florida and Texas. But this beautiful light show was a precursor to something far more dangerous. The storm's energy started to play havoc with our technology. Satellites orbiting Earth were a primary target. Japan's Kodama satellite had its systems shut down, while Russia's Express AM-1 satellite suffered permanent damage, its main communication bus failing entirely. The International Space Station had to take evasive action, putting its crew in a shielded area to protect them from the intense radiation. On the ground, airlines were scrambling. Commercial pilots and flight controllers were forced to reroute flights, especially over the polar regions, to avoid communications blackouts. The radio waves that planes used to communicate with the ground were being absorbed and scattered by the storm. In Sweden, a transformer at a power plant failed, leaving 50,000 homes in the dark. This was just the beginning. The main CME, the real killer, was still on its way, traveling at a speed so high that it was expected to hit our planet in less than 24 hours. And it was aimed right at America. The world was on the brink of an event that would make the Carrington event look like a firecracker. What no one knew at the time was that a tiny, almost insignificant decision made decades earlier would be the only thing standing between us and total blackout. The silent war in the atmosphere. The threat was real, and it was racing toward us. On the morning of October 29, 2003, as the main wave of the solar storm approached, America was a beehive of activity, completely unaware of the invisible war being fought miles above their heads. This wasn't a physical enemy with tanks and bombs, but a silent, unseen adversary, a colossal wave of charged particles that could bring the entire nation to a standstill. A historical warning. To understand the gravity of the moment, you have to look back to the most famous solar storm in recorded history, the Carrington event of 1859. Back then, our world was simple. The most advanced technology was the telegraph, a powerful solar flare hit Earth, and the sky lit up with auroras so brilliant they were seen as far south as Cuba. Telegraph operators reported sparks flying from their equipment. Some even received electric shocks, and a few telegraph offices caught fire. It was a spectacular but relatively harmless event, because our civilization wasn't yet powered by electricity. Our vulnerability was low. Now, fast forward to 2003. We've built an entire civilization on an intricate, sprawling web of electricity and digital information. Our lives are intertwined with a power grid that stretches across continents, satellites that beam data from space, and communication networks that connect us all. This incredible progress, however, had made us unimaginably fragile. The more technology we built, the more exposed we became. It was a ticking time bomb, and the 2003 Halloween storm was the fuse. The moment of impact, a direct hit. On October 29th, the full force of the CME struck. The speed of the charged particles was so immense that it compressed Earth's magnetosphere, the protective bubble that shields us from solar radiation, to the point where satellites in high orbit were suddenly exposed to the open void of space. This triggered the most intense geomagnetic storm since 1989. The effects were immediate and widespread. Communication satellites, the backbone of a global digital economy, started to fail. GPS signals became erratic, causing navigation problems for ships and aircraft. Even worse, the storm began to induce massive currents in Earth's power grid. Transformers, the crucial links in our electrical infrastructure, began to overheat and fail. In North America, power grid operators were on high alert. They had been watching the solar forecasts from NOAA, the National Oceanic and Atmospheric Administration, but the speed and intensity of this particular storm were beyond anything they had ever seen. Their goal was to keep the grid stable, but they were fighting a silent, powerful enemy. The near miss, the decision that saved a nation. Just as the storm reached its peak, a series of critical decisions were made that, in hindsight, saved America from a massive blackout. Back in 1989, a similar but smaller solar storm had caused a complete blackout in Quebec, Canada, leaving millions in the dark for hours. The memory of that disaster was still fresh in the minds of many power grid managers. They had learned a vital lesson. When faced with an overwhelming electrical surge from a geomagnetic storm, the best course of action is to disconnect the grid. As the 2003 storm raged, utility companies in the northern US and Canada did just that. They intentionally took certain sections of the grid offline to protect critical equipment. For a few tense hours, parts of the country experienced minor power fluctuations, but they were able to prevent a cascading failure. If they had not learned from the Quebec incident, if they had hesitated for just a few minutes, the entire East Coast and potentially a significant portion of the country could have gone dark. This was a classic Chekhov's gun moment, a detail from a past event that became the critical factor in averting a future disaster. The lesson of 1989, a tiny piece of knowledge passed down through the industry, became our shield, the fragile web. The crisis was averted, but the silence that followed was more unnerving than the storm itself. The Halloween storm of 2003 served as a stark, undeniable reality check. It exposed a fundamental flaw in our technological reliance, a dependency so complete that a few hours of solar wind could bring down the most powerful nation on Earth. While the public breathed a collective sigh of relief, behind the scenes, scientists, engineers, and government officials were grappling with a terrifying question. What happens when we're not so lucky? We live in a world of intricate, interconnected systems. From the satellite that routes your GPS to the power transformer that brings electricity to your home, every piece of our modern life is a potential casualty of a major geomagnetic storm. A solar superstorm on the scale of the 1859 Carrington event, if it were to hit today, would be a global catastrophe. The economic fallout alone would be staggering. A study by Lloyd's of London estimated that a modern Carrington-scale event could cause trillions of dollars in damage, shutting down everything from banking to transportation. The power grid would be the primary target. Geomagnetic storms create what are called geomagnetically induced currents, GICs, that flow through our power lines. These GICs don't cause a sudden blackout. They slowly cook and destroy the giant transformers that are the heart of the grid. These aren't your average household transformers. They are massive, custom-built pieces of equipment that can weigh hundreds of tons. There are only a few companies in the world that manufacture them, and the lead time for a single replacement can be months, if not years. If 100 of them failed across the country, it wouldn't be a matter of flipping a switch to turn the lights back on. It would mean a sustained, long-term blackout that could cripple society. The lessons we failed to learn. The threat was so clear in 2003, but the response was slow. The US government, while aware of the danger, failed to take the coordinated, large-scale action needed to protect the grid. There was no single organization or authority with the power to enforce regulations on utility companies to harden their infrastructure. Each company was left to fend for itself, a strategy that would have been disastrous in the face of a direct hit. This near miss should have been a wake-up call for everyone. It should have pushed us to invest in better space weather forecasting, to build a more resilient power grid, and to develop strategies for surviving a long-term technological dark age. Yet, the sense of urgency faded with the passing of the storm. The human memory is short, and we tend to focus on immediate problems, not on threats that might be decades away. We were living in the calm between storms, lulled into a false sense of security. But the sun doesn't care about our political squabbles or our economic priorities. It operates on its own timeline, and its next major storm is not a matter of if, but when. The looming threat, the next close call. For a moment in July 2012, we were face to face with the future. A CME, even more powerful than the 2003 Halloween storm, erupted from the sun. This one, too, was a direct hit. The blast was so powerful that it would have caused a global catastrophe had it hit Earth. But this time we got lucky. The storm narrowly missed us, passing through our orbital path just a week after Earth had moved on. It was a cosmic dodge, a moment of extraordinary luck that no one on the planet even noticed. NASA physicist Daniel Baker later remarked, "If it had hit, we would still be picking up the pieces." That's the terrifying reality. We're living in a highly interconnected, technologically fragile world, and the space weather forecast is getting more and more important. The sun is entering a new solar cycle, and the number and intensity of solar storms are on the rise. The path forward. The storms of 2003 and 2012 proved that the sun's power is not a distant academic concern. It is a very real and very present threat to our modern way of life. We are living in a ticking clock with a cosmic event of unimaginable power waiting to strike. So the question remains, what can we do about it? Lessons for a new age. The lessons from these near misses are clear. First, we need to invest in our infrastructure. This means modernizing our power grid with hardened transformers and protective devices that can withstand geomagnetic currents. It also means improving our space weather forecasting. While we can't stop a solar storm, we can predict its arrival with enough warning to take precautionary measures, like temporarily shutting down parts of the grid to protect it from a catastrophic overload. Second, we need a unified national strategy. The fragmented, state-by-state approach to grid protection is a recipe for disaster. We need a single federal authority with the power to enforce safety standards and coordinate a national response. A storm on this scale won't respect state lines, and our defense shouldn't either. Third, we as a society must understand our own vulnerability. We have become complacent, assuming that the internet and electricity are a given. The reality is that they are not. The next major storm could leave millions without power for weeks or even months, and we are not prepared for a sustained, long-term blackout. The story of the solar storms is a warning from the past and a challenge for the future. It's a reminder that even in our most technologically advanced moments, we are still humbled by the forces of nature. We can choose to ignore this threat, to sit back and hope that we continue to get lucky, or we can choose to learn from our close calls, to prepare and to build a more resilient future. The first step is to spread the word. If you found this story compelling, I have a request for you. This video is just one part of a bigger picture. The story of our world is full of moments when everything almost changed. I've put together a video that goes into another one of these events, a nuclear crisis that was far closer to disaster than we ever imagined. Click here to watch the full story of when America almost nuked itself, the broken arrow that didn't explode. I promise it's a terrifying story you won't want to miss. And if you want to see more of these stories that tell the days when everything almost changed, please hit the subscribe button. I'll see you in the next one.